I'm Jelte. I'm a Postgres contributor. I'm a maintainer of PG Bouncer and of PG.DuckDB, and I maintain PG.DuckDB while being employed by MotherDuck there at the top. So I know a bunch of things about DuckDB these days. And so I'll tell you what Postgres can learn. So first, what is DuckDB? Because it's a Postgres conference, so I can imagine many of you don't actually know. So it's a lightweight, in-process SQL analytics engine. And that means that it's similar to SQLite in that it's in process, but similar to Postgres. Actually, not really similar to Postgres. It's like similar to SQLite, except that it is an analytical database instead of a transactional database. So it's created by these two guys at the CWI, which is a research center in the Netherlands. They started a company to maintain it, DuckDB Labs, and they've been doing that so far. And I work for MotherDuck, which is a other DuckDB company that we host DuckDB in the cloud, and we pay them for consultancy with their DuckDB Labs consultancy company. So DuckDB has become very popular very quickly. So you see this nice graph up, and it only seems to go more up. And it's like the stars on GitHub, and it actually surpassed Postgres in stars. So it's clearly more popular than Postgres already. So, has to be good. So why is it so popular? It's because it's the Swiss Army knife of data. That's at least what it's trying to be. And why? What does that mean? It's like every data scientist can use this. And one benefit is that it is very good at parsing CSVs and sort of finding out types of CSVs of the columns. And all data scientists always have CSVs lying around and send through email to them and in like weird Google Drives. So parsing CSVs is very important. And secondly, it's very easy to install. Like Postgres can be quite hard to install if you don't know stuff about Postgres, but this is like, you just do your package manager and DuckDB, and then it's done. Or you copy paste like a curl command into shell, and then you have a DuckDB CLI that you can run, and suddenly you have a SQL interface. But you have a SQL interface to what? You have a SQL interface to basically anything. That's where sort of the power of DuckDB for data science and data analysis is sort of where it comes from. It has its own database file, like a .duckdb file, just like SQLite has a .SQLite file. But it can also read CSVs, JSON, Parquet. It can read and write to pandas and polars and all kinds of data frame libraries. And like Arrow is also a thing that people use it with. And it's not just good at reading and writing stuff. It's also reading and writing that from everywhere. Like all the file formats, you can get them from S3, from HTTP. You can connect to Postgres and connect to MySQL and just get all the tables and do queries that join CSV files and some Postgres table, for instance. So yeah, and then the next question is it actually fast? Because if you can join things together, fun, but if it's not going to be fast, why would you do it? And basically the answer is yes, it is really quite fast. I took a few of the results from the ClickBench benchmark. It's a benchmark from ClickHouse. It's a fairly simple analytical benchmark in that it only has one table and you just do aggregations and filters on that single table, so there's not a single join in any of the queries. And DuckDB is actually quite good at joins, but apparently it's also very good at looking at a single table because it's faster than ClickHouse at its own benchmark. It's also faster than Snowflake with a much larger instance, and it's a lot faster than Spark. And you might be wondering, why is Postgres missing on this picture? And that's because then suddenly all the bars kind of disappear. But I have a theory that that's mainly because the data set size just doesn't fit in RAM for Postgres. So you're basically benchmarking the GP2 disk of AWS on like how fast can I read all the data for every query. So, and I have a theory that maybe ClickHouse kind of chose that data size and that instance type just so that it didn't fit, but no one ever knows. So now we come to the real question. What can Postgres learn from DuckDB? Now that you have some introduction into what DuckDB even is. And there's basically three things. There's ease of use, because DuckDB is very, very easy to use. There's performance, and there's extensibility. And we'll go over those 3 points sort of step by step. So let's start with ease of use. Basically, DuckDB, it made what they called friendly SQL. SQL that anyone can sort of write, and not just SQL experts. And that's kind of useful. So I'll give a quick demo, if that hopefully works, but I think it does. Let's see. Let's go. Yes. Let me make this a bit smaller. All right. So this is using a feature that MotherDuck added this demo because it makes the demo really nice and smooth. It's called Instant SQL, and you will see how it works. So you can basically do from, and then it will automatically run everything. So we're going to look at this query, look at this data set. It's an S3 file, it's a Parquet file, and it just do from, and then paste it, and it will work. You will suddenly see the results. I don't even have to press run. I don't have to do anything. Basically, anything that I type will be automatically executed, and you will see the results. So as you can see, from without any select just works, and you don't have to specify types, and it figures out where to get this data, and it does all that sort of magically behind the scenes. So let's select a few columns. Let's start with the title and the rank, and let's see, the view. Oh, I forgot a comma. That's why it doesn't autocomplete. So it does autocomplete once there's a viewership score. So and it autocompletes because it already knows what's there because the from is there. So it figured out what the columns are. So let's also add type. Fine. So now we have a bunch of things. And okay, let's order this by rank, just to see how that goes. Order by rank. Okay, but it's all one. So okay, it's different. Oh, it's Netflix daily top 10. All right, so we have to do something else. So we make it. We do number times top times number one. Number one, and we'll do sum rank equals 1. We say that that's number 1. All right, so now we need to do something with the title because it's a group. Suddenly it's a group by. So we do group by title. Make this a bit bigger again. Here. So whole query fits. So group by title, viewership score. You can do average. You can use that as a method instead of as like a normal function. Just like sort of people expect that don't write SQL every day. That sort of these basic things are basically in every language except in SQL. So if you come from Python or JavaScript, SQL can be quite daunting because it misses so many sort of nice things. And yeah, so let's remove the type. And as you can see, it already works, even though I didn't remove this last comma. So it doesn't care about the last comma. So I can just remove columns at the end without having to worry about that. And it also like this is a capital letter T and this is a small letter t. So it will do case matching, sort of that makes sense. But you can see, there's all zeros, so I have to do desk. And then now this kind of looks all right. But this is all because it's like this on-the-fly execution. It's all sort of like it's with sampling, so you have to run the final thing, and then you get a result. But this is very big. Let's close that. Then you get the real result, and apparently Cobra Kai is like the most popular, like the most top one thing on Netflix for whatever period this was. All right, so that was kind of this demo. Let's go back to the other thing. Go back to the slides. So yeah, DuckDB has sort of syntax that makes sense to people that don't use SQL every day. I think that's sort of I don't even use SQL every day. I'm like, or I mean, I might use it, but I'm not a SQL expert. I'm like a programming expert, or hopefully I am. But I'm not like a data science. I'm not constantly writing SQL queries. So every time I write Postgres queries, I get lots of errors all the time. And with DuckDB, I have that a lot less. So the other thing that it does well is it has generic types. So it has a map type and a union type, and you actually get the real types back. And it has a struct, like we have in Postgres, we have the composite types, which are similar, but those are not. You have to always create them. They have to have a name, and these can be anonymous. Basically, you can have a function return sort of a new kind of struct. And arrays are also sensible, because arrays in Postgres, if you've ever looked closely at them, you know how weird and strange they are. And you can tell a table that it contains two-dimensional arrays, but you can put a single-dimensional or five-dimensional array in them, and everything is totally fine, unless you start to read it. And so DuckDB, you can either specify the actual dimensions, and then it will ensure that that's the case, or you can not specify and just sort of put any length of list of array in there. And you can do multidimensional stuff like this. So what about performance? What can Postgres learn performance-wise? Well, sort of the most obvious thing is like Postgres is row-based stored. So for analytics, that's generally not good, because it's good for transactional workloads, but for analytical workloads, you're scanning tons of data, and if you only need a few columns, you're still scanning all of the columns that you're not using. So you're doing a lot more I/O than necessary. So instead, DuckDB stores stuff in what they call a row group. So they have 120K rows that they group together and then the data they put in columnar format. So pick up at and drop off at are all the values for those columns. Like those are together with the other values of that column in the same chunk of data in the same row group. That way, all this, like you can do some nice things like compression. And instead of using normal compression like gzip or zstandard, instead DuckDB uses lightweight compression. And that's basically all sort of simple compression methods, like, oh, is all of this thing in this column, in the 120K rows, are they all null? All right, then we just store one null instead of like 120 of them, 120K of them. And if we don't have like all of the same ones, you can do run length encoding. So you say like first we have 3 W's, and then we have 2 A's, and then we have 4 X's. And then you sort of compact all that data together and store less. And the nice thing of doing these kind of things instead of the heavy, like zstandard or those kind of things, is that they're much more effort to decompress. This is much cheaper. And we also have dictionary encoding, so it's similar to the run length encoding, but it doesn't have to be in the same order. You basically have some enum values assigned to the actual strings, for instance, if there's all the same strings. And there's lots of other of these fancy, smart, lightweight compression techniques. One of them is fast static symbol table, and that's basically you can sort of build strings out of common substrings. So if you have email addresses, lots of them have @gmail.com. So that way you just store @gmail.com once for your 120K rows, and then you can sort of append all the unique bits to that. So, but storage is only one of the parts. Execution is also very important, and that is done using morsel-driven parallelism. It's a fancy word for we create small batches, or not super small, but batches of rows that we still store in like this, even in memory, even in the execution engine, we store them in this columnar format. So you have vectors of each column for all of the rows. And DuckDB uses, by default, 2,000 rows in like a single batch. It's called morsel in this paper, but they call it batches. And it's different from the Volcano model. in that it doesn't do one row at a time. It's like you get a batch of rows. And what's especially nice is that you pipe it. It's not just the batches, it's also the parallelism side is also very important, is that you sort of keep the batch that you worked on, you continue to work on it as far as you can on your CPU, so it stays close in the caches, and you don't have to transfer data across caches. So you don't have to, you don't have to move data across caches, and you can, if a CPU is not doing anything, it can steal some work anyway from one of the queues of the other cores. And the nice thing is that then you can still compress all this stuff in memory also. So it's not just oh, there's a bunch of benefits to that as well, because you can do auto-vectorization even if it's all the same. If it's all different values, you can still do auto-vectorization to sum them all together, for instance. But if you have like the dictionary encoding, if you want to append like a C to the A and the B, you just have to do it twice instead of doing it 5 times, because you can just do it to the dictionary instead of to the full load, like all of the values. So yeah, then finally there's extensibility. Postgres is kind of known for its extensibility. It's one of the first, or maybe the first, extensible databases. And DuckDB is also extensible. But one of the things it allows it has a package manager. So you can actually install extensions instead of having to figure out how to get all these bytes on your computer based on your OS, which is kind of a hassle with Postgres generally. Sometimes you have to compile, sometimes you have to install some other dependencies, sometimes you have to add like a yum repo or a apt repo. And it has FDWs, what I like to call FDWs on steroids. It's a way of attaching other databases. So this is how it works to talk to Postgres. So you can just say attach Postgres connection string, and then a name, and then it creates a new database that you can query like it was like a DuckDB database. You can use the DuckDB syntax on Postgres tables. And all this is actually, in Postgres, we also allow this triple schema thing. But the first one, we just we error out if it's any different. So it could very well be made extensible that extensions can claim the first option. So you can have an FDW that does this kind of thing. And you can also have custom file systems. So extensions can implement how and where you get data. So it supports reading Parquet files, it supports reading iceberg tables, but where that data comes from, that's just extensible. So if I create my own blob storage, if I have some FTP server with some random JSON on it, I could create an extension to read from FTP. And finally, this is one of my main gripes of writing extensions in Postgres, is that you have this split of SQL files and shared library files. And if you want this function that's executed in C, you still have to create the function in the SQL side and tell it that it needs to execute some C. But I mean, that's not really in DuckDB. That's just not necessary. You can just add it to some list of functions. So you only have a shared library in DuckDB. There's no SQL file. Everything that happens is in the shared library. It adds functions, it adds some tables. So it's a dynamic catalog. It's not a catalog that you have to update with SQL. And in Postgres, that's kind of annoying because when you update an extension, like when you install it, it's not so bad the first time. But for updating extensions, it's kind of annoying that when you update when you shared library, then your SQL stuff is still sort of the old thing. So if you write that shared library, you have to take care of that to be sure that it still works. It doesn't crash if you call it with the old arguments. While with DuckDB, if you just load the new shared library, you have the new functions. It's that simple. So yeah, that's kind of what I had to say. There's a bunch more, but I can't cover everything. So the DuckDB has a very good blog on internals and all kinds of things. So definitely recommend reading that. So yeah, I put a few links, like DuckDB itself, PGDuckDB, the project that I'm working on. Both of them are MIT licensed. So if there's any questions, I'm happy to answer them now or in the hallway.
Very much, Jelte. We still have the QR codes to scan over here and at the door. So before you leave, you can scan and give him a feedback. And right now we have a coffee break. Thank you.